I'm going to start by giving a sort of an overall sort of vision of what ArcGIS is to developers and how we've been evolving the architecture to better support developers over the last 10 years or so. And then we'll dig in very quickly through the client APIs and the extension SDKs. And I'll do that fairly quickly because we're going to dive into these deeper after lunch. So GIS is advancing rapidly. You probably got a sense for that from the talks this morning. And about 10 years ago, a little bit over 10 years ago, 12 years ago, we were thinking about the architecture that we had back then, and it was clear that the architecture that we had was not going to cope with this change as we could foresee it happening over the next 10 years. The types of data that you can now ingest into the GIS, the quantity of that data just is quite remarkable. And so we needed to think about how we're going to change ArcGIS to deal with that. The types of environments that you run your GIS is on. It used to be you were quite happy with a desktop and a server in your organization, several desktops, and you would be set. But it's not that way anymore. You've got desktops, of course, you've still got your servers, but you've got mobile devices, you've got cloud computing, you've got edge devices. They all still need access to ArcGIS and all of its capabilities. And so because of that, we started to think, what do we need to do to set ourselves up, not just for the next 5 or 10 years, but for the next 20, 25 years. And of course, GIS is evolving with lots of new capabilities. You saw a glimpse of some of these this morning downstairs from Mark, ArcGIS Knowledge being one of the latest that we've added in there. So when we started to take a step back and think, what do we need to do to prepare ourselves, we really decided to build what we feel is a modern GIS architecture around this concept of WebGIS. And WebGIS is very much services-based. So we have a common set of services. These services can be implemented on different technology stacks, but it's important that they still support the same sort of REST endpoints for clients to talk to them. And then these clients can be in a variety of forms, again with their own different technology stacks, but they're talking the same language, so it looks and behaves as one complete comprehensive system of capabilities. So why is WebGIS so compelling? I think Mark probably did a pretty good job this morning when he was illustrating sort of a quick pass through all of the capabilities of ArcGIS, but it's very accessible to end users to work with. And it's very interoperable. So you can be opening a map on your mobile phone, you can make an edit, you can close your phone, you can open it up in a browser, you can continue your work in the browser, you can then close your browser down, you could finish off your work on your desktop PC. It's the same map that you're working with, the same set of services, very different technology that's been implemented, but it's the same set of services, the same information products across the board. And so what we really have started to see is Jack has put this slide together a couple of years ago, and he's really recognizing that WebGIS is driving a digital transformation within organizations that adopt it. It's taking their sequential workflows and making them simultaneous. So what does that mean to you as a developer? Well, it's really significant because in the past, we had, if each sequential workflow was implemented with a stovepipe set of development technology. Maybe some of that technology was ArcGIS. Maybe some of that technology was open source. And you built these bespoke solutions to support a specific workflow. But now, users expect more. Users expect that interoperability. They just expect to pick up a map on their phone or their web browser and it just to work. Well, with these stovepipes of technology, that's not possible, or it's extremely hard to achieve. But with WebGIS, the architecture supports it by design. So we really see the WebGIS transforming the way that you as developers build your solutions. You can take your solutions and deploy them on all these different platforms, knowing that you've got a common set of services to rely on, a common information model to rely on, with these higher level information products like a map. And really, web maps are the fundamental component of the WebGIS architecture. They really interconnect everything together. And I've said it more than once this morning already, it's the map that your end users will probably interact with most of the time. So the ArcGIS system, there's 4 main pillars to the system. There's ArcGIS Pro, which is software that you can extend with your own custom add-ins. There's ArcGIS Enterprise, again, a software product to run on your own premise, and you can extend that with your own custom functionality. There's ArcGIS Online. That's software as a service where we take all of the technology and we host it on infrastructure and just make it available to you through the web and accessible through web browsers as well as mobile applications. And as a developer, you extend ArcGIS Online by building custom apps that make use of the services that are backing ArcGIS Online. And then with ArcGIS Platform, our latest developer offering, you simply tap into these services with a very simple pay-as-you-go consumption model. You just pay for what you use. And the big news about ArcGIS Platform, more than anything, is it's a new business model for developers to gain access to the capabilities of the ArcGIS system. So if I look at ArcGIS from really a developer's view here, you've got tools for automating and scripting, using the Python API and some of the DevOps tools. You've got SDKs for extending ArcGIS with the Pro add-ins and the Enterprise SDK for building server object interceptors and extensions. And then there's a whole set of client APIs ranging from runtime APIs for building native applications, APIs for building game engine-based applications, our own JavaScript API, as well as open source APIs that we now fully support for you to do your development. So you've got lots of opportunity to tap into the rich set of capabilities that come with ArcGIS. When it comes to deploying your solution or your applications, how do you actually go about that? Well, you can obviously build apps. That's probably the most common way of building a custom set of functionality for your users. You can take existing ArcGIS applications and configure them and extend them. You can build applications using no-code or low-code builder options. You can use our client APIs where you get access to all the capabilities of ArcGIS. You can extend our existing software products by building plugins and extensions to them. You can integrate with external business systems, often down at the REST API level, where you're just talking system to system, making REST calls. The reality is, for some of the larger implementations, you'll be doing a mixture of all of the above. And that's as was intended. The architecture supports you pooling all of these different technologies together, these different deployment options, but you're working with the same common ArcGIS system, the same set of services, the same set of information products built on top of these services. And that's really the power of this new modern web GIS pattern. So starting at no code, you could use our instant apps. This is where often your own end users author an application first by creating a map. Once they've got their map, they pick a template and they create an instant app simply by marrying up the map that they've created with the pre-written application. No development experience required, but it does allow them to deploy their their map in a more focused experience to better share that experience and mapping technology with non-GIS professionals. You could use story maps, which again builds on the concept of the web map, but layers on top of it the idea of storytelling with these preset styles that you can have with your story maps. Or you can build rich information products with ArcGIS Dashboard. All of these allow focused user experiences to be created by end users without writing any code at all. Now, while we've intended them to go to end users, you as developers can leverage them as well. There's no point in writing too much code if there's a way to do it quickly and more efficiently. That doesn't mean to say that you're not creating custom experiences. you are putting all of that authoring capability into the map itself. And you can author a lot of custom functionality by writing custom arcade expressions and custom pop-ups, and then publishing using these no-code options. Next are the low-code builders. We've had the web app builder for many years now. Many of you are probably using it. We continue to support that, although it's fair to say we don't actively develop web app builder anymore. For the web low-code builder, we're putting all of our energy into building out experience builder and getting it up to parity as quickly as we can in terms of the widgets and the capabilities that you would expect to see if you've been using the web app builder before. So web app builder is all about building focused applications from a collection of widgets. Experience builder, you can do that, but experience builder is all about building complete web experiences where you can build multiple web pages and feather in parts of custom sort of applications into that web experience. So it just allows you to build a richer experience for your users. And then App Studio is our low-code, no-code, native application building technology, and you can build applications to run on a variety of devices from Windows PCs to Macs to Linux boxes, Android phones, and iOS phones. So as developers, we build applications to empower our users with the custom experiences. And the way that we do that is we leverage APIs. So what I'd like to do now is just sort of take a step into the various API technologies that you use as a developer. So when you're working with an API, I really split them into two camps. There's client APIs that we use to build applications, and there's extension APIs that we use to extend the existing ArcGIS software that we at Esri ship to all of you. And our client APIs support building for web, mobile, and desktop, and our extension APIs support ArcGIS Pro on the desktop and ArcGIS Enterprise for server-side development. So let's have a look at the client APIs. First and foremost, the lowest level client API is our REST API. All of these web services that we develop, they all come with a REST API. We use that REST API to build the ArcGIS system, but it's also available to you as developers to tap into to build your own custom experiences above it, or maybe to connect IT systems together. You can do that at the REST level. For higher level sort of mapping applications, we have an ArcGIS API for JavaScript, which in its latest form, JavaScript 4X, that was completely rewritten from the ground up to embrace the WebGIS model. And that's why the JavaScript project reinvented itself with the 4X release of the JavaScript API. And also, we now support open source APIs, so that it's not just the JavaScript API you can use. You could use Leaflet. You could use MapLibre's GLJS. You can use Cesium if that's your preferred tool of choice as a developer. The system doesn't block you from doing that. In fact, we've enhanced all of our services to better support these open source APIs, and we've done that over the last couple of years. For native APIs, we've got the runtimes to support 5 different platforms. And then finally, we've got the Python API, which is a new Python API, or newish, it's about 4 or 5 years old now, sitting on top of the WebGIS information model. And you can use that if you're a data scientist to do data analysis, but you can also use it to script your GIS workflows sitting on top of WebGIS. So the REST API, it's been around for quite a long time because we've been developing these REST services, and these REST services have been getting richer and richer and richer, and along with it, so has the REST API. We really group them into 4 categories. There's our, if you like, our core location services, things like geocoding and routing, geo-enrichment. There's our GIS services, which take these a little bit further. Some of the analysis services are an example there. There's services to script and administer users and groups that are items in the portal, the sharing API, if you like. And then there's services to administer your enterprise ArcGIS. If you've not been to the developer's website recently, the documentation just got a complete overhaul, and a new version of it was released just about 4 or 5 weeks ago, just after the Developer Summit in Palm Springs. And it's been greatly sort of simplified and enhanced to really promote the REST API as a first-class citizen, along with all of our other APIs. It's not an internal API that we use and you don't have access to. In fact, we see it as often the most commonly used API of all the APIs that we release, because it does expose all the capabilities with unfettered access. Our JavaScript API, as I was saying, we completely rewrote it to sit on top of the WebGIS pattern. It's a very modern JavaScript API. There's no dojo, hooray. And for anybody who used to use the 3x API, you realize the benefits of that. It supports 2D and 3D. In fact, to write a 3D application is almost exactly the same as to write a 2D application. There's just a couple of lines of code that are different. When you initialize the view, you just say, I want to look at this web application in 3D, and it comes to life as in a 3D. It's very much data-driven visualization at its heart. It's the API that underpins the user experience of ArcGIS Online. And as you can see, the visualization enhancements move with ArcGIS Online, so they move with the JavaScript API because they're hand in glove, the same. And it really does help support really elegant and engaging user experiences on all the outlets that you would expect web experiences to be present. Whether it's a desktop, a laptop, a tablet, or a phone, you can build a great user experience. From its heart, it supports high-performance map display and interaction. And these come in two forms. There's how do I get the data from the server to the client as efficiently as possible, and how do I render it and handle it and manage it on the client as efficiently as possible. So we've both enhanced our feature services to be tile-based, so you can get requests on a repeatable query nature, so we can cache them on our back end. So you're just querying tiles of features, and there's a hierarchy of these for fast delivery. And then once they're there, we make use of WebGL to do rendering using the hardware that's available and supported by all the modern browsers. Other capabilities in the client to do analysis, we make use of, where possible, the local engines. So we've got a local geometry engine, projection engine, a SQL engine, all running client-side in the browser for improved performance. You no longer have to go back to the server to perform a geometry calculation. It's all done inside the browser using WebAssembly to power it. And we've got interactive scene analysis, where we use the graphics card and the 3D model on the graphics card to do our scene analysis. And of course, for some more heavyweight analysis operations, we do reach back into the server for network analysis and geoprocessing. So I've got a very short demo that Julie recorded here for me, just to show you a combination of both the SQL engine working on the client side, as well as the rendering engine, dealing with a fairly large amount of data in New York.
This app, built with the ArcGIS API for JavaScript, allows me to explore development and expansion of buildings in New York over time. As you can see, as I hover over the building footprints, I have access to both the geometry as well as the attributes. Having this information client-side is really powerful. I can perform queries, filter, and calculate statistics completely client-side. Now, this is a time filter that visualizes the buildings based on their construction year. It's interesting to look at the building statistics and watch the expansion and height of buildings change over time. Now, when I zoom out further, because we're rendering with WebGL, the app can display more than 400,000 building footprints. Even at this scale, I can still interact with the buildings. The power of the API's efficient querying mechanism, fast display of data, WebGL rendering, and client-side processing all allow for rapid display and very dynamic workflows that were never possible in the past.
Thank you, Julie. Okay, so as well as just the technology to power the visualization and with high performance and in 2D or in 3D, we've also worked on the user experience to make it possible for you to build beautiful user experiences within your web applications. And so it's been from the ground up, responsive user interface design, mobile-first principles, and all of the widgets that we do ship, we separate the business logic from the user, from the UI, if you like, the model, from the view model. So you can completely overhaul the experience from a visual aspect and still leverage all the same business logic from our work. When it comes to open source libraries, you've got choices. We've created an open source library, the ArcGIS REST.js library. It's not a mapping library. It doesn't allow you to build mapping applications, but it does allow you to build JavaScript applications that tap into the REST services. And it runs client-side or server-side, and it just makes accessing our REST services a little bit more straightforward. And that's available on GitHub for download. We have a plugin for Leaflet. Leaflet's the most popular open source mapping library that we see used against ArcGIS, and with good reason. It's simple and it's easy to use. And with the plugin, it allows you to tap into these ArcGIS services. Open layers, we've extended so it can work with our vector tile services. Mapbox GLJS, recently renamed MapLibre GLJS, we fully support. And you can use that for building applications. And Cesium, if you're building 3D applications, we also support connecting to ArcGIS services with Cesium. And there's more information in these URLs along the bottom of the slides. ArcGIS Runtime is our technology for building native applications. And developers build native applications because they want the best mobile experience possible. They want to utilize all the capabilities of the device. Probably the main reason developers will use ArcGIS Runtime is they want their applications to work and function offline in a disconnected environment or a partially connected environment. Runtime supports multiple platforms, and it is, just like the JavaScript API, is tightly integrated into the ArcGIS system. So why build a native application? I spent a good 10 minutes talking about how good our JavaScript API was, and it is really, really good, but there are reasons why you want to build native applications. Ultimately, you get the best performance. Our native SDKs and APIs run closest to the hardware to exploit all the capabilities of the devices. You can access all the peripherals that come with the device, or you can connect to a device, because these peripherals come with SDKs, and you can pair up our SDK with the device SDKs to utilize these devices. And you can use them offline. That's the main reasons why people choose them. The runtime supports 5 SDKs running on 5 platforms. You can see them up here. It has the same capabilities across all of these different APIs. And it does that because most of the functionality we write once in C++, and then we compile it for the various architectures. We make use of the various chipsets that you can see there, and we expose it through what we refer to as a runtime common API to these individual environments. And then these individual sort of APIs, they do, if you like, localize runtime functionality so that it's presented very naturally in a form that would be natural to an Android developer or a iOS developer or a .NET developer. So there are subtle differences in the API, but it's only that localization that brings out these subtle differences. The core functionality is exactly the same. They also perform the same on all the different device architectures. So if you're wondering which API to choose, pick the one that most suits your development needs. Don't pick it based on performance, pick it based on your needs. Runtime works with maps, just like JavaScript API works with maps. Obviously, it really organizes the layers. It contains your base maps, your operational layers, the metadata about the map. We like to say that runtime maps work online, offline, outdoors, and with the most recent release, indoors. So you can have a really mobile GIS in your pocket when you're working with Runtime. All of the layer types that JavaScript supports are supported by Runtime. They're just tapping into these web services and pulling the data down and then rendering it and working with it on the client. But Runtime leverages the power of the native device. So it has additional functionality that's only available to Runtime. So feature layers, it gets mobile geodatabase, geopackages, shapefiles, a whole array of raster formats, KML, annotation layers, ENC layers, package layers. They're all supported by the Runtime and allow you to work in a disconnected environment. Works with scenes if you're in 3D, and again, very similar to a map in concept. It contains all the layers. But what makes scenes special, and this is the same for JavaScript, it does introduce some 3D specialized content. So scenes can contain everything that you saw in 2D maps, plus they can add extra 3D specialized content. They can represent surfaces. They can represent 3D features. And they could have models. They could have integrated meshes, point clouds. These are all data types that are supported with Runtime. Runtime has a concept of overlays. These are temporary graphics that appear within your application, but they're not part of the map or the scene. They layer on top of that information product, whether they're just points, lines, and polygons, or whether they're images that are being animated across your map or scene. Analysis is supported by the Runtime. Analysis, obviously, from services, but Runtime, just like JavaScript, has its own local geometry engine. But Runtime also has its own network analyst engine running locally and its own geocoding engine running locally for really amazing performance client side. And again, it supports the common interactive 3D analysis tools where we make use of the 3D model that we've got loaded onto the graphics card to give us sort of real-time 3D analytics. Most recently, we've supported game engines. And these game engines are really allowing developers to build truly immersive experiences for their users. The benefits of using game engine technology, well, obviously, we get premium rendering experiences, photorealistic rendering experiences. But they also come along with physics engines and animations and particle systems where we can start to really model the real world using these systems, and we can get really amazing simulation in near real time based on these systems that come as part of a game engine. They support cross-platform deployments. So for mobile devices or Macs or PCs. But probably what's exciting to me, they come with a very vibrant existing developer community. These are developers that you could be working with to help you build out some of these experiences to satisfy the needs of your users. So the two game engines that we support, ArcGIS Maps SDK for Unity and ArcGIS Maps SDK for Unreal. Unity and Unreal we support. They're the two most common game engines available. We deliver our capabilities as plugins. They support local scenes as well as global scenes. And there's a subset of data formats that we support currently in the first release. Unity support will go final in 2 weeks' time, and Unreal will follow about 3 weeks later. So we're really close to being ready there. I've got a very quick animation here, which I will play and just talk over. So we can do our normal standard, take the elevation, drape an image on top of it, and navigate through the scene. That's obviously supported in a game engine. And you can make use of the game engine's atmospheric effects to just provide a little bit more realism to the scene maybe than what's possible with, say, the Runtime. But you can do more. And it's really when you start to interact with a game engine as a game engine developer, that's when you start to see the difference. That's when you start to see the power of bringing GIS content into your game engine. You're not bringing GIS programming patterns into the game engine. You're just bringing the GIS content. And here we have manipulation of that content by changing the shaders, writing custom shaders. These are techniques that game developers do all the time. And you can see the realistic on the right-hand side, artistic on the left-hand side. This is just by changing a shader. Here's an elevation model sort of effect that's being generated on the buildings of New York. Again, just by manipulating the shader that's working with the data. Here's another shader that's picking out the edges of the content. And I think the next one is another shader that simulates buildings at night. So that we're using the geometry of the building, and then we're draping on top of that a completely different effect that's been created solely on the game engine side with a custom shader effect to give us the effect of having buildings lit up at night and even generating interior surfaces. Again, all being generated by the shader, nothing to do with the GIS data that was used, that was just the building skin, if you like. But you're still working with the real world. As one of the big areas of development that we've been doing with Epic Games as well as Unity is a better manipulation of the geographic real world within the game engine, because before, game engines only worked in local space. But we've enhanced that. And here you can see where we've been using some of the other systems that come with a game engine, the simulation systems to simulate sort of live traffic and pedestrians. And with this last example, there's a drone planning application that's being put together to figure out where charging spots should be, how the drone flights maybe are impacted by no-fly zones, and then what's the visual impact of a drone hive if it's put down in a city. But you can also use it to simulate a real-world flight paths to see what happens if drones are going to collide with each other. These are all things that are possible with a game engine that would be quite difficult to do with our existing technology. So the final client API that I want to touch on today is the Python API. This is a pure Pythonic library sitting on top of WebGIS. You can use it to perform data science. You can use it to script and automate your WebGIS. And you can also use it for system administration of your ArcGIS enterprise. And depending on the type of work that you're doing, you may pick sort of a way to interact with it that's more natural. Maybe you're using the command line, or you'll use Jupyter notebooks, or you'll use some scripts that have been written by somebody else, or you'll probably use a bit of a combination of all of these, depending on the type of work that you're doing. But the Python API does support it all. Data science is one of the newest areas that the Python API has been getting used for. And it's really about asking the questions, well, what happened, where, and when? These are your typical GIS questions that we've been asking for years. Why did it happen? That's a typical GIS question. What will happen, where, and when? Okay, that's getting a little bit more into the data science field. But more importantly, if we know all of the previous three questions and the answers, what can we do about it? That's really the reason why data science is so exciting when it's paired up with GIS. So notebooks for ArcGIS are really if you like, the playground for the data scientists, but they're also the playground for you as a developer. You don't have to set up an environment. You can just open a notebook and start writing your Python code. Everything's there. Everything is hooked up for you. They're a great way to get started with the Python API. So that was a very quick tour of the client APIs. We will go into almost all of them in a bit more depth this afternoon when my colleagues come back after lunch. I just want to finish with the extension SDKs. There's really two extension SDKs, extending the desktop with the Pro SDK and extending the enterprise with the Enterprise SDK. So we'll start with Pro. The first thing to say is, with Pro, you don't need to write code to customize the experience. You could just go through and configure the UI to strip out some extra commands that are not needed on the ribbon, to add some more ribbon elements based on their context. You don't really write much code to do that. You can automate using Python and geoprocessing tasks. Or you can write your own add-ins to do more advanced work. And you do that using the Pro SDK, which is a .NET-based SDK. It's a modern framework. It's nothing remotely similar to the old sort of ArcMap, VBA, or ArcObjects API. It supports Visual Studio, and with the Pro 3.0 release, it will support the latest version of .NET and the latest version of Visual Studio. And there are really two ways to interact with it. There's add-ins, where you take, you create custom ribbons, custom elements to put onto your ribbon, custom UI components, and then there's solution configurations. That's really where you take over the complete control of the ArcGIS Pro's user experience. From the moment that the user clicks that icon to start, you've got the option to put a custom splash screen on, a custom start menu, and really a complete custom experience. And we use solution configurations to build dedicated applications that we sell that have nothing to do with ArcGIS Pro. They just use ArcGIS Pro as the, if you like, the framework, and we build all of the application on top of it using these custom solutions. So they're very, very powerful to use. Add-ins, pretty easy to share and install for your end users. You can make them secured, you can make them licensed, and they're delivered as a single file, so very easy to distribute. The solutions, as I said, they're a little bit more involved, and they take a lot more design thinking about how you might want to extend and interact with ArcGIS Pro with the solution. And then finally, ArcGIS Enterprise, we really have two options there for you: server object extensions, where you take our existing web services and you add on extra capabilities, extra operations onto that web service, which you then consume with custom clients, or server object interceptors, where you take our existing web service, you don't change its signature, but you're able to feather in custom functionality, either before the call goes through to the back end or before the call comes out from the back end. And Java and .NET are supported there. So server object extensions, server-side code, attaches to a feature or image service. The benefit of using our object extension is we manage the life cycle of that extension for you. So as the service spins up and shuts down, we will spin your extension up and shut it down appropriately. But any server object extension has to have an appropriate extended client to make use of it. In the case of server object interceptors, we don't change the signature, but you still can inject custom functionality into a web request. Maybe you need to perform some extra security before the request is allowed to go through. Or maybe you want to watermark the result of the request with some extra attribution based on the user credentials that are used to access it. That's all possible with the server object interceptors. But the best thing is our existing clients can work with the web service without alteration, because you don't change the REST endpoint signature when you build a server object interceptor. Okay, so to wrap things up, I don't really expect you to read this, but if this was on my whiteboard and somebody said, could you quickly draw a diagram of ArcGIS and what it means to a developer, it wouldn't come out as neat as this, but this is roughly what I would draw. At the bottom, we have a set of capabilities. That's what Mark talked about this morning. A wide set of capabilities that are that's what ArcGIS is. It's mapping and GIS capabilities. Above that, we have a set of products that bundle up these capabilities and make them available in various forms. We've got server, we've got enterprise, we've got pro, we've got platform, we've got online. But as a developer, you can tap into all of that based on what you want to do. Do you want to build web applications? Or maybe you just want to configure some applications, or you want to build an app for a device, or you want to build an app for a game engine. There is an API that allows you to tap into that set of capabilities. So in conclusion, our technology has evolved. It's not the ArcGIS of 10 years ago. It's the ArcGIS of 2022 that we have now. And it's completely different and evolved to make use of WebGIS and the services. It has a seamless integration with all the different modern compute environments that you're likely to encounter. And more than anything, it's open to developers with full-featured ArcGIS APIs or even open source APIs. So with that, I'm only 3 minutes late.